Alright, so let's go through these electrostatic questions. So if this tall building fitted with thick strip of copper, known as your lightning conductor, right? So the copper contain negatively charged particles. So for negatively charged particles, these are known as your electrons, and of course are free to move within the copper. So describe and explain what happened to the negatively charged particles in the copper when the thundercloud passes overhead. Okay, so assuming that the thundercloud, all these things right here are negatively charged. Okay, so what happens is that this negative charge in the cloud, in the thundercloud, will so-called repel all the electrons in the copper strip to the bottom. So let's just say, okay, I put bottom. After that, the top part, due to the absence of electron at the top part, so all these will be positively charged. Okay, so how do I explain this? Okay, first, you just say that, okay, the electrons in thundercloud repel the electrons in the copper strip. Okay, so this is the first credit. Then of course, okay, you want to add on also can. So say, the top part of the top part of copper is induced. Why do I say induced? Induced means that, okay, so it's induced with positive charge. Okay, induced means that it's not the positive charges that move, because positive charges don't move. It's only the electrons that move. Okay, so that's the first credit. Of course, don't forget the second credit. You just say, okay, because you look at this, right, the electrons here, so there's a so-called earth wire here. So when there's an earth wire, right, the electrons will flow to the earth. So meaning that all these electrons here will go down to the earth. So the electrons in copper strip will flow to the ground or earth via the earth wire. Right? Yeah, so there's two processes, right? First of all, the electrons in the copper strip get repelled to the bottom, and after that electrons will flow to the ground via the earth wire. So that's how we do this question.